Welcome back to geometry. We are going to continue. We are on rectangles, and they want us to label the rectangle love. That's quite a name for a rectangle, but we'll do what they want us to do. So, rectangle love, let's put point L up here. We'll put O in the corner. We'll put V down below and E. Now, when we think of a parallelogram, we know there are certain traits that this shape has, and remember that whatever all of these traits gets passed down to generation to generation. So here is our rhombus, okay, and then our rectangle. So everything that's true about a parallelogram is also going to be true about a rectangle, okay? But there will be one or two things in a rectangle that we don't find in a parallelogram, because these traits don't move up, the traits always move down. Okay, and then into our square, the square is going to have everything that's true about a parallelogram, a rhombus, and a rectangle. So the square has everything. So if I think about the properties of a parallelogram and relate that to a rectangle, we know that opposite sides are each congruent. All right, and then we also know that when we draw in diagonals, that diagonals will bisect each other. Okay, now I'm not going to mark this up the way we do a parallelogram because it's going to be different. And here's what I'm getting at. We know that in a parallelogram, we know these two marks are the same, and then we can put 2 marks here because these 2 lengths are the same. So this point acts as our midpoint. This point still acts as our midpoint between LV and OE. But if you just look at LV and OE, if you just go by looks, it appears that these segments are each congruent. Now, that's different than in a parallelogram, okay? But we have to prove this, okay? This isn't, I mean, it's going to be true, but we need to prove why LV is going to be equal to OE. Now, the other thing that a rectangle has that the parallelogram does not is it has 4 90-degree angles in the corners. So let's go ahead and add that. Let's change the color. We'll put 90 degrees, 90 degrees, 90 degrees, and 90 degrees. All right, next. If I separate this triangle lev, okay, so I'm going to call it triangle lev, and I'm going to say that triangle lev is congruent equal to triangle OVE. Now, we need proof for this, okay, so here's our proof. If I were to redraw these shapes, and let's redraw LEV. So here is triangle LEV. Let's redraw it. I'll try and draw it just the way it looks. Okay, 90-degree angle. Here's L, here's E, and here's V. Now on these marks, we have a 90-degree angle at E. We have 2 marks at LE. We have 1 mark on EV, and that's what we have. Next, if I look at triangle OVE, let's try and draw that. It's going to go the other way. And there's our 90-degree angles. Here's O, here's V, and here's E. And I can put 2 marks here and 1 mark here. And we can see that these 2 triangles are each congruent. Why? Because of side, angle, side. Side, angle, side, side, angle, side. So these 2 triangles are each congruent by side, angle, side. And as a result, if these 2 triangles are each congruent, that means by CP/CTC, LV has to be congruent equal to OE. So LV, segment LV is congruent equal to OE, to OV. There we go. Okay, and that's by CP/CTC. All right, well, the last thing that I want to say is, since segment LV is congruent equal to OE, sorry, let's change this to OE, excuse me. Since these 2 diagonals are each the same length, we want to say that the diagonals of a rectangle, are each the same. They're each congruent. Okay, well, if this is our midpoint of each diagonal, then this length, I'm going to put 3 marks, is equal to this length. Okay, but it's also true that this is the same length as well. So that's what makes a rectangle different from a parallelogram. One, we have 90 degree angles. The other is that these diagonals are each congruent. So all of these lengths will be the same. All right, since squares are always both rhombus and rectangle, then all of the properties for them hold true for squares. So here's what we can say. Since A is true in our parallelogram, that these diagonals will bisect each other, it's also going to be true in a rhombus, in a rectangle, and in a square. B, diagonals are perpendicular. That's true in a rhombus. It'll also be true in a square. C, diagonals will bisect opposite angles. That's going to be true in a rhombus. It'll also be true in a square. And D, diagonals are congruent. That's going to be true in a rectangle. Therefore, it'll get passed down to the square. All right, first shape is a rhombus. That means these diagonals will bisect the opposite angles. So since this angle is 78, angle 1 is also 78 degrees. Angle 2 has to be a 90-degree angle. The intersection of the two diagonals are perpendicular. And if I have 90 degrees here and 78, that means angle 3 has to be 12 degrees. Angle 4 is going to be the same as angle 1, and that's going to be 78 degrees. Rectangle, we have PS, this piece right here, as being 6x minus 4. We know the entire length GI is 28. Well, since this is our midpoint, we can put 14 and 14. Since this is a rectangle, this piece is also going to be 14, and 6x minus 4 has to be 14. 6x equals 18, x is equal to 3. All right, our last shape. We're told that ABDCD is a square. Sorry about that. AB is 20. Therefore, BC is 20. Therefore, CD is 20. DA is going to be 20. Now, if all of these are 20, and we're asked to find the length of a diagonal, then let's create a right triangle. So we have a right triangle with 20 and 20. And you guessed it, a squared plus b squared equals c squared. 400 plus 400 equals c squared. 800 equals c squared. Radical 800 would reduce to rad 100 times rad 8. This becomes 10 rad 8. Rad 8 becomes 2 rad 2 multiplied by the 10, and that gives us 20 rad 2. And if we divide 20 rad 2 in half, 20 rad 2 over 2 would be 10 rad 2. That means BE is also 10 rad 2, CE is 10 rad 2, and then DE is also 10 rad 2. All right, angle ABE. Angle ABE, these diagonals will bisect the opposite angles. So all these angles are going to be 45. So we get 45, 45, 45, 45. Angle CDE is also going to be 45 degrees. And 45, 45, and 45. Which means angle AEB, that's our big angle inside. Now these will create 90-degree angles at the center. So we have 90, 90, 90, and 90.